Hello everyone, my name is Ahmed Al-Baghdadi from Kent State University. It's an honor to present to you our paper titled Topic-Based Community Search over Spatial Social Networks. This work is a collaboration with my PhD supervisor, Dr. Shang Lian. In this talk, I will go over introduction, problem formulation, problem definition, solution, experimental evaluation, and finally conclusion. Recently, with the increasing popularity of location-based social networks such as Twitter, Foursquare, and Yelp, the community search problem has drawn much attention due to its wide range of applications. The community search problem aims to obtain dense communities in an online manner based on a query request. Some applications of the community search are events organization, which is an application to create a small or large-scale event such as conferences or conventions. Friend recommendation, which is one of the fundamental applications in social network that recommends new friends or groups. The community search can also be used to identify groups or communities of social network friends to offer them group discounts to visit certain merchants. Motivation example. The figure to the right illustrates a social network Twitter dataset where each user is associated with keywords that are Twitter hashtags from user accounts and has checked locations on road networks. Each edge between two users is associated with social influence probability. The community of user in this example is a topic-based community search over spatial social networks, or TCS SSN community, because it satisfies the following. Users are forming a strongly connected component on the social network, such as they are friends or share common friends. Users are spatially close such that they are located in nearby places on the spatial road network, or they basically live nearby each other. The users in this community have a high degree of social interaction or share similar topics of interest. One application is that we can offer this community a certain discount to go visit certain merchants as a group. Previous work on community search problem have considered community semantic by spatial cohesiveness only, topics of interest and social cohesiveness only, community with the higher outer influence, and other work consider the social and spatial cohesiveness. In contrast, in this work, we propose the topic-based community search over spatial social network to find community of users that has a high social cohesiveness, spatial cohesiveness, and high social influence among the community member. Spatial social networks. We model social network as a graph where vertices are social network users and direct edges represent friend relationships between any two users. Each user is associated with a set of keywords that represents one's skills or profile information. Each direct edge has a weight vector with respect to a certain topic, such as basketball or technology. Each weight on that edge represents the social influence probability based on that topic. Next, we model the road network as a graph, where vertices are intersection points and edges indicate road segments connecting those intersection points. A social network user has one or multiple check-in locations on the edges of the spatial road networks. Finally, we define the spatial social network as the combination of the social network with the road network. Now, we introduce our spatial social community, or SSTrust, in spatial social networks. We want to obtain a spatial social community with high structural cohesiveness, satisfying KD trust. And for any two users in the spatial social community, or SSTrust, their average road network distance of their check-in locations on the road network is less than a threshold. And finally, we wanted the influence probability for any two users in the spatial social community is greater than a threshold theta. In other words, the spatial social community is a set of social network users that have high structural cohesiveness, high spatial cohesiveness, and high social influence among the community members. Finally, we define our topic-based community search over spatial social networks as a retrieving of the maximal set S of social network users such that the query vertex is present in the final community. The community S is a spatial social community as we previously defined it, and every user in the returned community covers at least one query keywords. The straightforward approach is to enumerate all possible users, check their query predicates on the spatial social networks, and return the TCS SSN query answer. Thus, in the worst case, there's an exponential number of possible combination of user groups. Therefore, in this work, we design effective pruning strategies to reduce the search space. Then, we devise indexing mechanism and develop efficient topic-based community search social spatial query answering algorithm by traversing the query index. We introduce effective pruning techniques that utilize the topic-based community search properties to reduce the search space and facilitate the online community search query processing. The first pruning method is the spatial distance-based pruning, which utilizes the upper bound of the average spatial distance to prune users located far away from the query vertex over the road network. Second is the influence score pruning that relies on the upper bound of the influence score to roll out users with low influence scores. Third is the structural cohesiveness pruning, which filters out users where the maximum support of an edge induced by the user is less than k-2. The fourth pruning method is the social distance-based pruning that filters out users that are far away from the query issuer over the social network. Finally, our keyword-based pruning rolls out users that do not share any keyword with the set of query keywords. To facilitate the pruning, we design a social spatial index that utilizes information from both social and spatial networks to partition the social network users into subgraphs. The subgraphs can be treated as leaf nodes, where users at these leaves are spatially cohesive, socially cohesive, and have a high mutual social influence. Then connected subgraphs in the leaf nodes are recursively grouped into non-leaf nodes until the final root is obtained. To do the grouping, we design effective cost model that utilizes the social and spatial information to group the users into users and tree nodes. To answer the topic-based community search social spatial network query, we traverse the social spatial index, starting from the root down until leaf nodes. We use a minimum heap to enable the tree traversal. Each time we pop out an entry from the heap, we apply pruning methods to check if it can be pruned. After the index traversal, we will be left with a very small group of users that will be refined to return the actual answer. We tested two real data sets that are Guala Social Network combined with California Road Network and Twitter Social Network combined with San Francisco Road Network. We also tested two synthetic spatial social network data sets following uniform and Gaussian distributions. We implemented three baseline algorithms that are greedy, which greedily look for the answer without using an index, S-index, which utilizes the social information to construct a tree index over social network users, R-index, which constructs an R star or a tree over users' spatial and textual information or road networks. Our results show that our proposed method outperforms the baseline algorithms in terms of CPU time and I/O cost. In conclusion, we formalized and tackled an important problem, topic-based community search over spatial social networks. We designed effective pruning methods to reduce the search space. We also proposed a novel social spatial index over the spatial social networks. Also, we developed efficient algorithm to process our query. And finally, we evaluated the efficiency and the effectiveness of our proposed query approach over both real and synthetic data sets. Thank you so much.